This video is for 13.3's lesson. So we are going to be working on more volume problems today. So our goal is to use our formula of length times width times height to find that volume. And we're also going to be working backwards today and finding unknown sides. So it will give us the volume. We have to work backwards to find one of those dimensions. So if you can find the volume with decimals and simple fractions that cancel out or are very just those benchmark fractions, 1/4, 1/2, things like that, then that is a 3. If you can find the volume with just whole numbers, that's a 2. And if it gives it to you and you can count the squares and the boxes, that's a 1. So to bump up to a 4, you've got to be able to use mixed numbers and find the unknown dimensions given the volume. So that working backwards part bumps you up to a 4 and using just harder numbers. So let's jump into task 1 today. So task 1 tells us, let me move my head. So task 1 tells us that Lyon is making this toolbox shown. So let's list out the dimensions that we know. So we know the length here is 6.8, and our width going backwards is 3.4, and then the height from bottom to top is 2.3. So now we want to plug in our dimensions into our formula. So we don't know the volume, so we're looking for the volume when the length is 6.8, and then we'll times the width of 3.4 and times the height of 2.3. So we're going to start and do 6.8 times 3.4. So go ahead and try that part. So don't forget to move your decimals. And then, so pause the video, do that, and come back and check. So 8 times 4 is 32. 24, 25, 26, 27. I'm going to cross this off and put my placeholder. 3 times 8 is 24. 6 times 3 is 18, 19, 20. So we add these up. 2 and 11, 3 and 2. And I have 1, 2 decimal places. So moving it 1, 2 decimal places. So 6, this is almost practically 7. And here's about 3.5. 7 times 3 is 21. So it should be a little bit more than 21, which is what we have. So now we have 23.12, and we need to multiply that by 2.3. So when we multiply decimals, we do not need to line them up. We just count and move them over when we are finished. So go ahead and pause and try that problem, and then come back and check. So 3 times 2 is 6. 3 times 1 is 3. 3 times 3 is 9. 3 times 2 is 6. So I don't have anything to cross off. So I'm going to put my placeholder. 2 times 2 is 4. 2 times 1 is 2. 2 times 3 is 6. And 2 times 2 is 4. So we're going to add these up. We've got 6, 7, there's 11, 12, 13, and 5. So I have 1, 2, 3 decimal places. So I need to move my decimal 1, 2, 3. So we end with 53.176, and these are inches cubed. So make sure we get that label to show that it's volume. That's what fits inside of that toolbox. So now he wants to paint his toolbox. So he knows how much he can fit inside. So now he wants to paint the outside of the toolbox. So that means we need to find the surface area. So what we're going to do is we're going to find the front dimensions. So we've got this rectangle here. So we've got this rectangle that's dimensions are 6.8 and 2.3. And we have that front and the back. So we've got two of those. So we're going to do length times height, or base times height, and we have two of those. Now let's look at our sides here. So the height is still 2.3, and our width is 3.4, and we have two of those. And now we need to find the top piece here. So its length is 6.8. And then it goes back 3.4. And we have two of those. So our formula is we have two of everything. We have two of 6.8 times 2.3. And we're going to add on, plus we have, I didn't mean to put that parenthesis there. So, and we have 3.4 times 2.3, and we have 6.8 times 3.4. So we have each of those sides. So we're going to find the front, the side, the back, or the top. So we found each of the sides, added them together, and then we're going to double it, is how you would write that formula out. Or you can just do it piece by piece. Find this one times by 2. Find this one times by 2. Find this one times by 2. So now we need to do all of that work here. So there was one number we did. What did we do? 6.8 times 3.4 is 23.12. So let's save ourselves some work. So 6.8 times 3.4 was 23.12 for one of those. So we found the bottom. So when we found the volume, we found the bottom, the base, and then we found how many layers of that we had. When we're finding the surface area, we're not stacking that same thing over and over. We're finding each different side. So we need to double 23 point, so this one, let's see, was right here. So 23.12 is 6.8 times 3.4. So we need to double this. So go ahead and multiply that by 2. Is 4, 2, 6, and 4 with 2 decimal places. So this one here is 46.24 for this was the red one, the top and the bottom. So let's try our front one here, 6.8 times 2.3. So 6.8 times 2.3. So go ahead and try that. Pause the video and come back when you're ready to check this part. So 8 times 3 is 24. And 18, 19, 20. And we've got a placeholder. Going to cross this off. 2 times 8 is 16. 2 times 6 is 12. Plus 1 is 13. So we're going to add these together. 4, 6, 5, and 1. 2 decimals. So this is close to 7 and 2. 7 times 2 is 14. But we have a little bit more, so that makes sense. It's a little bit more than 14. So, but remember, we actually have 2 of these. So that was just the front. Now we need to find the back as well. So we're going to times by 2 is 8 and 12. Here's 10, 11. 2 plus 1 is 3. So the top and bottom together. Here's the front and the back together. So now we just need to find these sides together. So go ahead and find one of the sides, base times height, and do that part there. So 4 times 3 is 12, 9, 10, placeholder, 2 times 4 is 8, and 6, adding those up, we get 7.82 because I have 2 decimal places. And 3 times 2 is 6, but they're a little bit more. So that makes sense. It's a little bit more than 6. That's just for one side. Now we need to find the other side. So let's go ahead and find that other one here. So timesing by 2 is 4. 16, 14 plus 1 is 15. 2 decimal places, 15.64. So we found all 6 sides. Now we just need to put them together. So we want to add all of these up. So 31.28, 46.24, and 15.64. And because we're adding, we do want to make sure all of our decimals and places are lined up. So here's 8, and 8 makes 16. Here's 6, 7, 8, 9, 10, 11. Drop my decimal down. Here's 11, 12, 13. And 4 makes 8, and one more is 9. So our surface area is 93.16 inches squared because we could unfold that flat. We're just finding 2 dimensions at a time. So even though, yes, we found all of the different pieces, at a time we only used 2 of them. 2 here, 2 here, 2 here. So now it asks, if 1 tube of paint covers 40 square inches, how many tubes should he buy? So I'm just going to make myself a little chart here for tubes, and this is how much it covers. So 1 tube will cover 40. We can see that's not enough. If I have 2 tubes, 2 times 40 is 80. Still not enough. And do you think if you go to the store and they'll just say like, oh yeah, you can cut that tube in half and just take what you want? No, they're probably not going to do that. So if we buy 3 tubes, 40, 80, 120, yes, you'll have some extra, but it's always nice to have a little extra just in case. But if he only buys 2, he's not going to cover all of the surfaces. So he's got to make sure he buys enough to cover everything. So he'll need to buy 3 tubes and have some left over. So go ahead and use all of that information and complete task 1, and then come back when you are ready to do task 2. So task 2 tells us that a company makes cereal boxes that have a volume of 432 and a fourth cubic inches. So we know the volume of this whole box. So you could fit 432 cubes that are an inch in dimension inside that box. The dimensions of the cereal box are shown. What is the width of the box? So first, let's write down what we know for the formula. So we know volume is length times width times height. Now let's plug in and substitute the values that we do know. So our volume we know is 432 and a fourth. So our length here is 9.5. 9.5. I'm having a hard time with that too. And our width is W. We don't know our width. And our height from top to bottom is 14. So how can we find the width here? We need to get W all by itself. So what can we do to get W by itself? Well, we need to get 14 and 9.5 to the other side. So we're going to do the opposite. So I see some fractions here, and I know when I'm multiplying and dividing, we need to have improper fractions. So let's go ahead and do that now. So start with this one since it's a little easier. Let's get it. So 9 times 2 is 18 plus 1 is 19. So this is 19 halves. This is 14 over 1. We still just have W. We don't know. So let's do this one. 432 times 4. So go ahead and try that one. So here's 8 and 12. 16 plus 1 is 17. So 1728 and one more is 1729 over 4. Okay, so let's start actually and put these together. So then we only have to move one thing over. So since we can multiply 19 halves and 14 over 1, let's start with that. And then we can just move that over to the other side here. So we have 19 halves times 14 over 1. So let's go ahead and do 19 times 14. So go ahead and do that and come back when you know that answer. So here's 36, 4, 5, 6, 7, placeholder 9, 1. So here's 6, 16, and 2. So we've got 266 over 2. So our problem now looks like 1,729 over 4 equals W times 266 over 2. So we need to get this to the other side here. So the opposite of times is to divide. So we're going to divide by 266 over 2, which cancels this out to a 1. And now we have to do this to the other side. We've got to put it back behind. This is what we have. This is what we're dividing by. So 1729 over 4 divided by 266 over 2. Now remember, when we are dividing, I don't know if 266 can go evenly into 1729. So what I can do though is make it a multiplication problem, since division and multiplication are just opposites of each other. So I can copy this first one, 1729 divided by 4, keep the first one the same, dot, and flop here. So I can see a little bit of this. I know easily cancels out. This becomes 1, this becomes 2. So I know 2 can't go into this one. So I'm just going to leave these and we'll figure that part out. So 1729 times 1 is pretty easy. And now we have 2 times 266. So go ahead and do that. So there's 12, 12, 13, and 4, 5. So we've got 1729 over 532. So we need to do 1729, and we're going to divide by 532. So I don't know about you, but I do not know my 532 multiplication facts. So what I am going to do is I'm going to make myself a list over here. So I know if I times it by 1, it's 532. So 532 and another group makes it 4 and 6 and 10. So 1064 would be if I times it by 2. So let's go ahead and add on another group of 532. Makes that 6, 9, 5, so 15. 97 is if I do 3 groups, or 96, 15, 96. And I know I can't get another group in there because 15 plus another 500 is going to be about 2,000, and that's too small. So I think this will get us started here. So it takes a little work up front, but then the rest of it should be pretty simple. So 532 can't go into 1, can't go into 17, can't go into 172, but it can go into 1729, 1, 2, 3 times. 3 times 532 is 1596. So let's subtract here. 9 minus 6 is 3. We need to borrow. 12 minus 9 is 3. 6 minus 5 is 1. So we are left with 133. And so let's see what happens if we add on a decimal, if we can get it to a nice even number. If it doesn't, then we can just go ahead and put it back as a fraction. But I think we'll have to do some simplifying here. So I'm going to drop this down so I can see that's too big. So it goes in there 2 times, which is 1064. And so we're going to borrow here is 6. To borrow again, 12 minus 6 is 6 and 2. So now we're at 266. So I'm thinking, oh, and then we're going to bring down another 0. So I know, right, if I do it 1, 2, 3, 4 times 5 is about 20 something. And that's, I think, a little bit too small. So let's try 5. Whoops, I don't know what I'm writing there. 532 and see if it goes in there. Let's try 5. So 5 times 2 is 10. 15, 16. Ooh, looking good so far. 25, 26. Oh, perfect. It goes in there exactly 5 times. 266, 0, 0 left over. So, that was a lot of work to find that missing piece, but we can do hard things. So, it is 3. And since it gave these other ones in fractions, I think we should give this as a fraction. So we could have simplified 133 and 5/32. I just didn't know a number that went into both of them off the top of my head. So for me, it was easier to do a decimal. I know when I have a quarter, that's 1 out of 4. So the width here is 3 1/4. So since it gave it in fractions, we want to give it back in fractions. We can use that decimal though, right? 25 out of 100, because this is in the hundredths place, equals 1/4. 1/4 is 1/4. So let's just recap that problem there. That was a lot of work. So we started with our formula. We wrote out what we know. We made things improper since we're working with fractions and multiplying and dividing. So we combined the problems that we do know, because we do know the length and the height, then we can use that commutative property of multiplication to multiply different parts first. So we found that here, and then we had to get that to the other side. So we divided on both sides. And remember, it has to go behind the part you already have, not in front. This is not 266 over 2 divided by this. You've got to start with what you have, the total, divided by the piece. So we copy, dot, flopped, multiplied, and then we just had to simplify, which came out to 3 1/4. So go ahead and complete test 2, and then come back because we are going to do just a few other practice problems here. So we're going to go over the additional practice problems here. There's just 3 of them. So I just think we could use a little more practice with some of these more challenging problems here. So it says a fruit basket is shipped in a cube-shaped cooler. So what do you know about cubes? Cubes have all sides exactly the same. So the length, the width, and the height all have to be the same. And how many sides does a cube have? Has 6 equal sides. So the surface area, so the outside is 1,176. So first, it wants to know what is the area of each cube. So this is for all 6 sides, and we just want to know one of the sides. So to start here, we're going to take 1,176, and we're going to divide that by 6. And that's going to tell us each side, each area of the cube. So go ahead and do that. So next, we've got to figure out what are the dimensions of the cube. So this is just for one side here. So let's go ahead and do this here so we can talk about B. So I know 6 can't go into 1, but it goes in here one time, which is 6. 57, 6 goes into 57 9 times. 9 times 6 is 54. 3 left over, and bring down the 6. And it goes in there exactly 6 times. So the area of each cube of each side is 196 inches squared. Now I need to know what times itself. So remember, a cube is the same. So something times something is 196. So let's just start with some reasoning here. I know if I do 10 times 10, that's 100. So it's got to be bigger than 10 by 10. If I do 20 by 20, 2 times 2 is 4 with 2 zeros. So 20 is too big. So it's somewhere in the middle here. So, right, I know 12 times 12 off the top of my head is 144. Still not big enough. So it's somewhere between 12 and 20. So see if you can find the number times itself that equals 196. And that is going to be your length. It's going to be your width. And it's going to be your height because it's a cube. All of the faces are the same. So find the number times itself that equals 196. And then you're going to use that to find the volume, length times width times height. So we can use what we know to work backwards and find that information. So find the number times itself that equals 196, and then plug that into our formula, length times width times height, and go ahead and solve that. Number 2 tells us that a shoebox has these dimensions, and it wants to know the volume. So length here is 14 3/8. And we're going to multiply 7.5 by 5. So since we're working with fractions, we need to make them improper. So we need to do 14 times 8 is 32. 8, 9, 10, 11, so 112 plus 3 more is 115 over 8 times, here's 14 plus 1 is 15 over 2 and 5 over 1. So I know 2 can't go into any of these. I know 8 can't since it's also even. And all of these end in 5. So it looks like nothing simplifies, but they're not terrible numbers here. So we'll start with the bottom. 8 times 2 is 16 times 1 is 16. So now let's do 15 times 115. So 115 times 15. So go ahead and do that part and then come back and check. So here's 25, 5, 6, 7, and 5. Placeholder, 1 times 5 is 5, times 1 times 1. And here is, so 1725 is this first part. And now we need to times this by 5. So I chose to save the 5 for last. I could have done 15 times 5 first. That would have, and I just wanted to save an easy part for last. So 5 times 5, 25. 10, 11, 12. 35, 36, 5, 6, 7, 8. So this is 8,625. Now we just need to simplify. So 8,625 divided by 16. So I'm actually going to erase this problem here so I have some room to work. So I don't know my 16 times tables. I know a few of them. I know doubled is 32. Add 16 more is 48. And then I know it goes to 64. So 6 more makes 10. And so I think the next one is 80. And then we would have 96. So 16, 16, 16, 6. So each time, right, I can see I'm adding on 6, right? 6 plus 6 is going to be end in 2. 6 plus 2, 8. 8 plus 6 is 14. So we carried 1. And plus 6 is 10. Plus 6 is 6. So I think that should get us going here. So I know 16 can't go into 8. So I'm looking for 86. That's too big. So it goes in there 1, 2, 3, 4, 5 times is 80. 6 left over, bring down my 2. So looking for 62. That's too big. So it goes in there 1, 2, 3 times. 48. So we need to borrow here is 4 and 1 and 14. Bring down my 5. Oh, so let's add on another one here. So 96 and 16. There's 12, 9, 10, 11, 112. So I think we can go some more times here. So let's add another 16. 128. Let's try one more here. Is 14, 4. Woo, there we go. So goes in there, this 144 goes in there 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Oh, I didn't put my number up here when I brought my 2 down. Oh no. Okay, so 216 went in here 3 times. Okay, yes, I definitely need that. And now I brought my 5 down. 16 goes into 145 exactly 9 times. Or not exactly, almost exactly. And we have 1 left over. I can just keep this as a fraction since it gave me my problem as a fraction. So 539 and 1 out of 16 inches cubed. So I knew this wasn't going to simplify, so I didn't need to keep going because 1 is already as simple as it can get. So we just took each of these, made them improper, multiplied, simplified. Hey, let's do one more here today. So a watch company ships watch boxes in large boxes. The watch box and the shipping box are shown. So here's our shipping one. Here's the watch box. So first, what is the volume of the shipping box? Oh, we love these numbers. So the length is 6, the width is 4, the height is 2. Okay, go ahead and do that one. And then part B wants to know the volume of the watch box. And even though these are fractions, so this is what I was talking about at the very beginning about these are simple fractions. They're not mixed numbers, they're pretty small. So the length is 2/3, the width is 2/3, the height is 1/2. I notice I can even cancel some of these out. So 2 times 1 is 2. 3 times 3 is 9 times 1 is 9. So now it wants to know how many watch boxes can you fit in the shipping box. So you're going to take this answer here. So I'm going to call that S for shipping box. So you're going to do that part on your own. So shipping box, and we're wanting to divide by 2/9. So we're going to copy. So take your shipping box total, dot flop. If you need to put this over 1, do that. So whatever your shipping box is, times by 9, and then you'll cut it in half. Now remember, we can't, if it doesn't go in there perfect, we can't fit half of a box in there. They can't cut the watch. I mean, they could cut the watch in half, but I don't think they want to do that. So see how many of those fit inside there. Hey, good work today. I know that these are some hard numbers, and I promise I made some mistakes in there. I had to cut some parts of the video out. It just wasn't working out. I just erased it and tried again. Okay, you can do this. If you need any other help, let me know.